Okay, so hi guys, can you hear me? Hello?
Yeah, we can hear you.
Okay, so good morning, everybody. My name is Kodri, and I will be representing the loan prediction group. Um, so basically, these are the group members of, from loan prediction group. I don't need to run through everybody's names, but these are the members of the group chat of the group. So basically, our task was that XYZ is a company which connects borrowers and investors, borrowers and investors basically. And the problem was the issue of defaults, like loan defaults. So the company wants to automate the process of identifying people who are going to default on a loan. So basically, that was the problem statement. I do not know if I'm still audible, if you can still hear me.
Yes, you're audible.
Yeah, we can hear you.
That's fine. So basically, that was the problem statement. Although, excuse me. So yeah, like I said, the goal is to help XYZ develop a model which will correctly predict those who will default and result in a loan charge of being when individuals default on their loans and they're not able to repay these loans. So basically, the structure with the approach we use in carrying out the project is the basic machine learning approach, which involves basically loading up our data. Then the next thing we did was to formulate some hypotheses based on just surveying our data and surveying our data and formulating some hypotheses based on the view of our data before carrying out analysis. Then we went on to data cleaning because we had a lot of work to do in data preprocessing of the data because the data wasn't really ready to be fitted into the model. Then we had EDAs, that's calculated data analysis, then built our various models based on different algorithms, trained these models, made predictions, and where a lot of issues came up to was testing accuracy and measuring the model performance, choosing the metric to use to measure this performance based off feedback from last week's presentations. So this really came up with issues, and although not completed yet, we hope to get more feedback from the panel. So perhaps my network is really bad. Someone trying to say something.
Sorry, can you mute yourself? Okay.
Let's say something.
No, it was just nice. You can go on, please.
Okay, so like I said, after earlier, after importing and loading our data in, we made some hypotheses based on the look of the data. So the data had different features, and following the based on those features, we tried to predict that okay, so for the loan applicants with higher level of incomes, and normally a loan applicant with the higher level of income should stand a higher chance of loan approval, and also the lower the loan amounts, the higher the chance of approval, and also the lesser the loan period, the higher the chance of loan approval. People with good credit rating should also have a higher chance of loan approval. So basically, these are just hypotheses formulated based on the outlook of the data, and this is like our expected outcomes from the data, but not necessarily the actual outcomes we got after analysis. So basically, these are some plots of we observed from the data, like during data processing and after processing and pre-processing. So this is like a cross tab of the various features relating to the target variable. So this is some form of bivariate analysis. So here, for this first, we took a plot of the applicant's education as it relates to the loan status, whether the loan was approved or not approved. So I mean to say, like, so from the graph we can see that the number of approvals for graduates is slightly higher than the approval of non-graduates, which seems logical. And also the other part of the graph shows the credit history. So it shows that but it shows a higher number of not approved loans for individuals who have a credit history of 0, which is that's like a bad credit history or credit rating, while it shows more approvals of loans for individuals with a higher credit rating. So this kind of agrees with our earlier hypothesis that individuals with a good credit history would stand higher chances of getting their loans approved. Also, we took also other bivariate analysis on other features like the applicant's income and the co-applicant's income. Although we had varying inference from this analysis, from the graph of the applicant features of the applicant income as it relates to the loan status, we can't really infer much because it seems like it's kind of evenly matched for each being, because we categorize beings of low income, average income, high income, and also very high income. While for the co-applicant income, it kind of shows that there's a higher chance for individuals with low co-applicant income to stand a better chance of getting their loans approved, which seems kind of weird, but we came to the conclusion that it might be so because some individuals don't have co-applicant income, and also this led us to some part of future engineering where we had to combine these two, the co-applicant income and applicant income, to get another feature called total income. So basically, this is just a heat map showing the various correlation between the different features of the data before we fed it into the model. So the heat map here just shows the correlation between the different features in the data set. Sorry, I'm coming, sorry. Oh my god, I think I edited some pages. Okay, so basically after our data processing, we went on to test different algorithms on the data. We used the logic function, logistic regression, based on we used the k-fold cross validation on the logic function. Also tried XGBoost, which is a model ensemble technique. Tried decision trees algorithm and also the random forest algorithm. This is where most of the issues came up, because after just testing on these algorithms, we had to decide on a metric to use to actually judge these algorithms, because it from the feedback we got last week from the other presentations, it was said that we shouldn't just be focusing on the accuracy metric, which can be a little bit one-sided and all. So basically, due to this shows the various results we got from different models. I decided to use this focus on sensitivity and precision. This is due to the fact that the requirement of the model is to predict the to effectively
Hassan. No, not Hassan. Busede. Are you there? Hello, Busede.
Hi.
Okay, I think we lost him. Let's give him a while to join the call again.
You can pause the recording. Kelechi.
Sorry?
You said I was suggesting that you pause the recording.
Oh, okay. Boss said the.
Okay.
Okay.
Can you hear me?
Yeah, we can hear you.
Okay. Am I screen showing right?
Yes, it is.
Okay. So basically, this is where I stopped. So I was talking about the various metrics from the models we used and why we chose the metrics. So basically, we chose sensitivity and precision because sensitivity tries to capture all the to make sure the model isn't capturing negative as positive, and also to sorry, sensitivity make sure the model captures all the positive values, while precision is trying to ensure that the model doesn't capture negative as positive. And this is applicable in this case because the task was to correctly classify defaulters of a loan, and it would be a worst case scenario if our model classifies a an individual who is going to default the loan as someone who is not going to default the loan. So basically that's a false negative, and that's what we're trying to avoid in the model. So basically that's why we choose the precision and recall or sensitivity as the metrics to use to classify the model. Although I had a lot of problems with deciding on these metrics, and also it actually computing them, because it seems like sklearn itself has a specific I won't call it a method or way of calculating this, and our problem is like the opposite. So basically, it calculates on like being true positive being the probability of the the instance of correctly predicting a one value as true positive, where in our case here, the zero value is predicting the zero value is actually the true positive. So it seems like it's the reverse of the case, which this is one thing I really like to hear from the panelists, and it's more like a question, because it seems like the reverse is the case for our problem, since normally if you call a precision call method or a recall score method on the model, it calculates predicting a one value as true positive, while in this our case, since we are predicting the instance of being a defaulter is zero and instance of not being a defaulter is one. So it seems like reverse is the case in this scenario. So that's one thing would like to get clarity upon. So basically, after computing these different metrics on the different models, it turned out that it was basically with the logit function where we had the highest sensitivity and precision, which wasn't really high, but precision was about 34%, while sensitivity was about 64% on the logit function. Also, we tried it on the decision trees, and we had sensitivity of about 26%, precision of about 31%. Also, with the ensemble technique,
I have a question.
Yeah.
Okay, we'll take questions after his presentation. Yeah. You can go on, Bossede. Bossede, you can go on.
Hello?
Yeah, I can hear you.
And it's really acting up.
No, it's not you. Continue.
Okay, so basically, we tried it on the XGBoost too, and the random forest, which really don't know if this is from my end. I'm really hearing a lot of
It's
background
not.
noise.
It's not from your end. Just go on. Sorry.
So basically, we tried it on the XGBoost and the random forest model.
Someone is, I think, trying to go on. Close again. I'll fix this.
I have a question.
Okay, I think putting this on Twitter was a bad idea. Go on, Bossede, please. Take down the link immediately.
Can I go on now?
Yeah, go on. I think this is from those who are joining from Twitter. But go on, please.
Okay, so basically, we tried the same thing on XGBoost and random forest, and we returned really low sensitivity and precision score. So basically, sorry, excuse me. So basically, from all the models we tried, if we were to use the metric which we picked with sensitivity and precision, it's basically the lossy function which we would still be using as the model, even though it has a low precision score. However, the accuracy score of these various models varies, and it kind of improves as we use the different ensemble methods. Basically, just to reiterate the challenges we had most of the challenges came with processing, where we had missing values, and we used different approaches to filling these missing values. But some of them we used BFU for them, and some of them we used filling with the mode and the numerical values, while we filled the numerical values with the mean, while the categorical values with the mode and BFU. Some features were in text form, so like that's the categorical variables. So, and those variables couldn't go into our model. So to trace that, we had to use the get dummies from pandas to one-hand encode those data. Also, there were a lot of outliers in data too, so we had to remove them by taking the log to kind of make, because when you have outliers, the data is kind of skewed to the left. So we tried to remove these outliers to properly balance the data. Also, some features were not in the proper data type, so we had to convert those features to proper data type. And basically, which the main problem which I was talking about earlier is deciding the metric for the measurement of performance and issuing recommendations based off of the problem type. Sorry. I think his slide is missing. Sorry. So basically, that's it. We decided not to conclude yet and show recommendations, because we still have to work on those figures as they are not accurate enough, and we'd like to hear feedback from the panelists as to what to do when faced with this kind of problem. I don't know if I'm still audible. My network is really acting up today, and this is not easy.
You're audible. You're audible. Okay. Okay. I don't know if Bossede, you're still on the call, yeah?
Okay, Bossede is female. Quadri was the one that presented.
Oh, okay. Sorry. Quadri. Is Quadri still on the call? Okay, I would want him to join the call before I call any of the panelists to give their feedback.
Well, for me, it was a bit hard.
We can't hear you, Demi.
To actually follow what he was actually presenting. I don't know why.
Who, Demi?
Yeah, can you hear me now?
Yeah, I can hear you now.
Yeah, great. So I was like, it was a little bit hard for me to follow like the presentation, and I kind of heard like he had some questions, but I mean I couldn't really get it exactly, probably because of the distortions and like yeah, so I may not really have like much of an input. Yeah, because I didn't really like get everything. Yeah.
Is Quadri on the call now? So maybe you can ask the questions again.
Yeah, I'm back.
Okay, so Udeme says he's not really clear on the questions that you asked here, and then I'm really sorry for the disturbances here. So maybe you can ask your questions again.
Okay, so thank you, Udeme. What I was asking is, so basically we got our we successfully built our models based on different algorithms, and we've gotten our predictions. So now the issue now is deciding a metric to use to evaluate the model and to recommend a particular model to be used. So based on what most of you on the panel said last week's presentation, the normal route of just looking for the accuracy is the model. If I'm not quoting you guys wrong, it's not the appropriate way or the accurate way, right?
Well, there's how do I put it? Like I can't say there's an accurate way or there's this particular metric is not accurate. It all depends on
On the
what
problem.
you're trying to solve. Yeah.
Okay, yeah. So basically, the problem here is to properly predict the forecast of a loan, since the company it's a loan agency or a borrowing company or mortgage firm. So we wouldn't want to have instances where we would predict someone who is not who is going to default the loan, someone who is not going to default the loan. And if I'm not mistaken, that's like a false negative, right? I don't know if you can hear me. So basically, my question is that's my question. So my question is, since we want to do that, so basically I think the appropriate metric to use to judge that should be sensitivity, that's we call or precision, since we're trying to minimize all instances of false negatives. But now my question is based off on like when you are trying to do that with sklearn and from your confusion metrics, like I feel normally it predicts one as a true positive value, but in this case here, the value for one is an approved loan, which is an approved loan, and the value for zero is the it's a defaulter's value. So one is non-defaulters and zero is a defaulter. So it seems like it's kind of the reverse of the case than it is normally, where one is the positive value and zero is the negative value. I don't know if I'm making any sense.
I think I get to Quadri. So it's basically just convention. You can decide to say, okay, if sklearn is strict on the values of one, what one means, and the values of what zero means, and then you decide to use sklearn, then you as the engineer, you can either decide to know what understand that this is the pattern of sklearn, and then you change your what they call it, your labels here. You change the values of your labels and make your ones zeros and your zeros one. But I believe that if you're using sklearn, there should be a way, if I've not checked the documentation too, but there should be a way of specifying how your labels are structured, right? Okay, George, do you have anything to say?
Well, what I can say about his presentation was more or less like he did like an update of what those guys did last week, which is kind of cool. So it's not just about giving us an executive summary of what the problem is, but also going into details. I think that's a good one. Like the visualization was okay for me, and it looks as if he seems to understand the kind of problem he's solving. Also, I have another question. What's the meaning of co? Is it co-applicant income? What's the meaning of that? Hello, can you hear me?
Yeah, I can hear you, but I think he left the call again.
So
Can
okay,
any of his group members like explain what co-applicants income mean? Since you guys all worked on the project together. Maybe Bossedi.
okay. While we are still waiting for that, um, also I like the fact that he didn't bother. You know, that he didn't bother. He didn't concentrate more on using accuracy. Like he needed to look into other metric, which is a good one, because accuracy does not sometimes it does not really have any meaning. Like it's just arbitrary. But I like the fact that he concentrated on sensitivity and precision. Yeah, so, which is more or less like you're bothered about how confident your model is. And also, based on his question, I think the way to go about it is redefining what it is. Like, okay, 0 in SKLM might mean something else, 1 might mean something else, just like how you explained it. So I think it has to do with redefining the problem. Maybe what you can also do is just change the values. Sometimes you don't necessarily have to like fit into a particular setting. Sometimes you can, when you read the documentation very well, there should be like a way to go about it. But another thing you can do is just flip the values. But ideal, I think, it's like the negative of the other one. So it doesn't just make any sense flipping the value. You already know the kind of problem you're trying to solve. So it doesn't work. The scaling doesn't work well with you, but you know what you want to solve. The fact you know what you want to solve means that you can solve the problem. So sometimes trying to like follow a particular convention might not work out well. You can just read up on the document, look at how you can tweak, or you can look for another way of going around it. And I don't like personally. It is a good presentation, and another thing we should always think about is the consequences, like the business consequences of this kind of model. So yeah, you need to start thinking about that. So okay, accuracy is not good. Maybe sensitivity and precision is awesome. Okay, now what is the implication of this model in real world? Like if we should deploy this model, maybe we should try it out. How does it perform? Like we'll just like try a couple of like, instances. How does it perform well? So these are things you need to like look into, because now there's money involved, and once there's money involved, technically there's life involved, because someone is in charge of the money. So that's something we need to look into. So for me, the presentation was quite let's just give maybe it's just as a result of external factors like internet and co. But I had like some more questions to ask, but I just felt like a lot of things happened during the presentation, but it's not really an excuse. So that's my own input from this. And other people that have questions, they can also ask their question. Maybe let's see what it is.
Okay, yes. So sorry, just to add about, I mean, what you should use to calculate. I mean, since you were talking about sensitivity, I mean, you could also, since you said or the data set or the model is kind of like a flip, you could also look at the specificity, basically, because it's like while the sensitivity actually focuses on like the positive how do I put it? Like the ones, like depending on if your model was focusing on one to be like default or not. So you can also look at specificity, which will also be like a flip of that. I mean, you could also check that out basically. So it can help if you don't want to, go through re-engineering the data and then changing the values and all of that. Yeah.
Okay. Thank you, Josh. Thank you, Daniel. I just felt I should chip in one thing also. So George was saying something about, we are dealing with money now, and we need to be very, very careful about the model we are building. And that brings me to something that is also important when you're dealing with cases like this. So for the group that presented this and every other person who is interested, you can also try and look at something in machine learning called model interpretability. So sometimes you might want to know the reason why your model is behaving in a particular way. You might want to know why your model is giving a particular person a loan and why it's not giving another person that loan, right? Because if you decide to deploy such models for industrial use, cases might come up where your model will decide not to give a person a loan, and then cases might arise, and then you might be required to defend the reason, defend your model, right? Defend that choice that your model choose, and that's where model interpretability comes into play. Okay, so in general, it was a very good one. Thank you, Bossede. I don't know if Bossede is on the call now. I'm sorry, Quadri rather. I don't know if Quadri is on the call now.
Yeah, I'm here. I can hear you.
Okay, so you got the feedback